Hi, this is Miss Wenslaw. Today I will be reviewing skills that are required for AP Physics 1. To get started, these are all the topics that we're reviewing. You don't have to watch all of it. I'm going to list the times for each of these topics in the comments. So, we have a couple different things that are pretty important. One of the ones I want to note is algebraic relationships. This is the one where a lot of students find this the most challenging. Additionally, looking at Trig 2 is going to be important to us, so making sure that you review that before this class. I'll also go over a little bit about the equation sheet, which you'll get the second week of school. Like I said, don't worry about watching all of this, just go to the section you need. All right, so we're going to start with rearranging equations, which is definitely one of the most important parts of this class. So rearranging equations can really help us out with a lot of different skills that we need. So it's important to remember that we use PEMDAS, but we use it backwards. So we start with addition and subtraction, division, multiplication, exponents, parentheses. So keep that in mind when you're doing these problems. It's really important during this to also show all of your work and write out your steps. So I'm going to go through two different examples that are actually real life equations we use. So for this one, we are going to solve for AX, okay, which is acceleration in the X direction, okay. So let's get started. Now, I first have to start with addition or subtraction, so I'm going to move both of these over all in one piece to the other side, okay. So it's important to always remember that we're going backwards. We are not doing our normal PEMDAS, okay. Now at this point, I need to do some multiplication, okay, so I can move this 2 using that reciprocal to the other side. Now here's something important to note, because this is one of the biggest mistakes that I see. As you notice, my 2 is multiplied by everything, so it's super important that you keep that in the back of your mind when you do this, or we'll have some issues. Finally, I divide by t squared. No, I don't have to do anything to the exponent, okay? So this is my final answer. At this point, I can plug in my variables. Our second one we're going to do is a inverse. So we're going to solve for r. Now, the best way I want to do this, I need to get that r at the bottom. So I'm going to do my multiplication on both sides. And at this point, remember, I'm solving for r. So now I need to move this acceleration to the other side as well. So I'm going to make r equals b squared over ac. Nice little relationship for you. All right, next is talking about scientific notation. So typically in physics, we write most of our numbers in scientific notation, look like this, because it's easier for us to understand. Unfortunately, as humans, we are not the best at looking at big numbers and understanding what they mean, okay? So as some reminders, when I move to the left, like in this one, that means I'm going to have a positive, but when I move to the right, I'm going to have a negative. One way to think about it the other way is that my small numbers are negative exponents. Now going the opposite way, which we may not always do, if we have a big number and we have a positive exponent, we're instead of going to the left, we're going to move to the right. We have a negative, we're going to switch that and move to the left. Okay, so let's try this out with a couple examples. Okay, so 300 million meters per second. So I start with my decimal point here, and I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have 3 times 10 to the 8 meters per second. Okay, so big number, so we're going to have a positive exponent. Let's look at this other one. So let's move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of a big mistake when we have these smaller numbers is not putting the decimal after that number. So I'm going to have 5 times 10 to the negative 9 centimeters. Small number, so we have a negative. Next one, 5.4 times 10 to the 4th meters. So I'm going to move this guy over 4 times. 1, 2, 3, 4. So I can write that out. Not too bad. My last one, so this is a negative, okay? So I'm going to move this over 3 to the left. Let me write this out a little better. Move over 1, 2, 3. So 0.007 liters. All right, let's move. All right, so we're going to move on to algebraic relationships. This is the section that I find students find the most challenging, which honestly kind of makes sense because it is challenging for really anyone. There are a couple different ways to do this, and I'm going to walk you through them. You can kind of pick the one that works best for you, but number substitution seems to be the best one. So let's look at this first problem. As x increases, y stays constant. What's going to happen to z? So let's write this out. Equals y. So we're increasing x. That's going to be our important thing. So for number substitution, I choose a number for each. Okay. So whichever one stays constant, I'm going to make 1. And for our first one, we are also going to make x 1. Okay. This is like our comparison. So I have z equals 1 over 1, which is 1. Now I need to figure out what's going to happen as I increase x. So we're going to keep y the same. That's the most important part about this. And now I'm going to change x to equal 2. Okay, so let's plug that in. I have z equals 2 over 1 equals 2. So now I can compare these two numbers. Okay, so as as x increases, z is also going to increase. Okay, so number substitution is one of the best ways to get started. So we always start out with our starting numbers. I always like to do ones, and then we increase or decrease whatever the number is that's in the problem. Okay, so let's try another way. All right, so here's our second way. And this is rearranging equation and then number substitution. Now, if you remember our previous problem, we didn't have to do that because z was already on the correct side. So we're going to look at this one. As x increases, z stays constant. What happens to y? So here is our equation again. Now we're looking for what happens to y. So we actually need to solve for y first. Okay, I'm going to do that quickly here and bring y to the other side. So y times z, x. Okay, and then I'm going to divide by z, another nice inverse relationship, which we'll talk about in our last section. So here's our rearranged equation, and I'm going to do the same thing I just did on the previous one, but I'm going to use the rearranged equation. So we're going to set x equal to 1 and z equal to 1. Okay, so I'm going to get y equals 1 over 1, which is 1. Now remember it says x increases, so I'm going to make x equals 2, z equals 1. So now I get 2 over 1 equals 2. So looking at my comparison numbers, okay, once again like the previous problem, as x increases, y also increases. Let's move on to our last, and I think kind of our most advanced way to go through these problems. And these are our mathematical relationships. So these are like direct relationships, inverse, square, anything like that, okay? So let's look at this one right here. As y increases and x stays constant, what happens with z? So to start off, we don't have to rearrange, which sometimes you may have to in this type of problem, okay? So in algebraic relationships, we're not plugging anything in. We're really just thinking about what we know from math already. So this one says, as y increases and x stays constant, what happens to z? So I know that this is an inverse relationship, okay? So as this number goes up, so as my y increases, that's actually making my number less. So that means z decreases, okay? If we look at my first one, so 33 here, I have that x increases. That means z increases because that's a direct relationship. So this is our third and kind of most advanced way to do it. I can still rearrange the equation. And if I'm trying to do this mathematical relationship and I'm not sure, just stop and plug in your numbers. All right, let's move on. 2 more problems, okay? So we're just gonna do a couple of these so that you can think about, and I'll let you also kind of work on them alone. So I'd like to pause this video in a moment, okay? And I'm gonna tell you what to do. So as M increases, what happens to P? Okay. Our next one, as V doubles, what happens to A? Finally, this one, as F increases, what happens to T? So pause this video right now and see if you can figure out what happens. All right, so I'm gonna go over these ones, and I'm gonna do these mostly based off of algebraic relationships so you can see them, but if you do them any other way, that's totally cool. So for this one, as M increases, P is also going to increase because that's a direct relationship. Over here, so I'm saying that V is going to double. Okay, so this is a really nice one to actually plug things in. So we'll first make this all go to 1. Okay, and then I'm going to double V. Okay, so I'm going to have 2 squared over 1 is 4. So A is going to increase by 4 times. Okay, and that's, we have a square involved exponential. Last one. So this is a nice inverse relationship. So as F increases, my T is going to decrease. Let's move on to our next section. All right, so we're going to move on to unit conversions. Now it's really important when we do these, we think about a few things. And that first part is that we are always crossing our bridge, okay? And we are also always showing that the actual units are canceling. Okay, so we're going to start out with 10 miles to kilometers, okay? So this first part always has what we start off with. Now, if there's nothing on the bottom, like miles per hour, our second example, what we're going to do is put a 1 down here, so we double check we don't put anything there, okay? Now I'm going to kilometers, so I need to find something that goes between miles and kilometers. If you flip to the last page of your summer packet, you will see that there is a common unit conversions. There's also some metric conversions that is on your AP Physics sheet, okay? So if you look at this, one of the ones we can use is 1 mile equals 1.609 kilometers. Now you may have found another one, and that's fine. There are always 2 to every conversion. So I'm going to get 16.09 kilometers. Now, it's also important that you take a time to make sure that your units actually cancel out here, and you're left for the one that you actually need. So let's move on to a little bit more challenging one, and that's going from miles per hour to meters per second. Okay, so let's draw a bridge, maybe a bigger one here. Okay, and I'm going to start out with 5 miles, and then I'm putting the 1 hour here. So miles per hour is a fraction, so I have to make it a fraction in my bridge. So we gotta decide what to convert first. I prefer to convert the top first, and we are going from miles to meters. So first, I'm gonna use the same conversion as before. So 1 mile equals 1.609 kilometers, and I can X out my miles. Now, I'm not looking for kilometers. I am looking for meters, okay? Now, if we talk about metric conversions, okay, there are 1,000 meters in 1 kilometer. So I can have 1 kilometer and then 1,000 meters. Once again, I can cross that out, and I am left for meters right here, okay? So, got that done. Now I need to convert hours to seconds. So this is an important part. My hours have to go on top, 1 hour, so they actually cancel. A pretty good trick conversion here to seconds that may be on your page, I can't remember, is that there's 3,600 seconds in 1 hour. And once again, I can cross that out. So now I'm ended up with meters per second. So I could multiply and divide that all out, and I get 2.23 meters per second. Now, when you do these problems and you go from miles per hour to meters per second, you will often find that it's approximately half-ish of your miles per hour. Okay, so our last one is going from 10 miles cubed to kilometers cubed. Okay, so we're going to get started by making our bridge, and we're going to put down our 10 miles cubed. Okay, now I'm going to use the same conversion I did before. So I have 1 mile and I have 1.609 kilometers, but I have this little cube, so I actually have to cube both of these. Okay, very important. When I do these, I have to cube the number, using the number as well as the unit. Okay, so for my final answer, I'm going to get 41.66 kilometers cubed. I've been asked before, why don't I cube my number I'm starting with? Well, it's already cubed. Okay, it's already measured in miles cubed, so we don't have to touch that. Let's move on. All right, so metric system conversions are pretty important for us to be able to read them. Now, this is also on your AP Physics equation sheet, and it should also be on your common conversions. Okay, so for this one, we are going to do 3 kilometers into meters. Okay, now how do I do this? Well, let's look here. I have kilometers right here, and I'm going to meters down here. We can see I have a multiplication factor of 10 to the third. So for meters, I can put 3 times 10 to the third meters. Okay, so I'm looking at my conversion factor, or my multiplication factor, over on the side. Next one, I'm going from 15 milliseconds to just regular seconds. So here, I'm going from milli to my base unit. So this one is going to be 15 times 10 to the negative third seconds. Last one, I'm going from 25 centimeters to a meter. So I'm starting at centimeters and I'm going to a meter. So I'm going to have 25 times 10 to the negative second meters. Okay. No, I didn't put these in proper scientific notation, but that's fine because I'm just trying to get those metric system conversions. All right, so trig, one of a very important part right from the start in AP Physics, okay? So it's important when we look at our angle, which is right here, adjacent is always right next to it, and my opposite, if this was a light shining from the angle, over here, and then I have my hypotenuse, okay? So let's just try some examples. I know many of you have already done this in trig, but it's a really good idea just to review before we get started. So let's say that this angle right here is 30 degrees, okay? And let's say that I shoot a bow and arrow at 30 meters per second. And I need to figure out my x component and my y component, okay? So let's try this out. So this one is my hypotenuse, this is adjacent, and this is opposite. Now I really like to write those in so I don't do it backwards, okay? So let's start out with our x, okay? So I have SOHCAHTOA, okay? So for this one, I have my adjacent and hypotenuse, so I'm going to use co. So I have cosine and of 30 degrees, adjacent, which is x, over my hypotenuse, okay? So from here, I can rearrange and solve for x. So for my y, I'm going to use sine here because it's opposite in hypotenuse. So I have sine of 30 degrees equals y over 30 meters per second. So this setup is probably one of the most common ones we have in all of physics. When we do some vectors, it may look a little different, but still use this same sort of trig sequence. So you may see some patterns as we go through this course. All right, so talking about graphing, I'm just going to briefly go over this. So when we're looking at physics, in general, science, we always make sure that our x and y parts of our graph, our axes, always have the unit. There's so many graphs that I look at that have no units. Most important part about this. Next, we're often going to look for the slope, okay, which is our rise over our run. Especially in problems like this, it's really important to look at, okay, I have a positive and I have a zero slope and I have a negative, because that's going to tell us things about what we're looking at. So when you're looking at graphs, I really want you to focus on the slope. What is the number for the slope and what does that actually mean? All right, so we're winding down our lesson here, and next I'm going to talk about the scientific method and how this actually plays into our course. So we always start out with our question or our problem statement. So most of the time you're going to get this from me, and then I'll often ask you to kind of revise it. After that, we have our background. So if we are looking at equations, this is where you derive them, you explain them, you talk about units, the purpose, all of that. That's going to be one of the most important things in this class and probably one of the most challenging. For a hypothesis, we may do it, we may not. It kind of depends on the lab, okay? Then we're going to test it and really see if our procedure is working, because a lot of times you're going to write a procedure, may not work, you got to try again. Finally, when you get your data, we're going to analyze it and we're going to communicate our results. So we do a lot of lab reports in here, but we'll also do some other forms that are not lab reports, which are consensus circles or share outs or posters, where you'll be able to share your findings in a little different way. Okay, so when we are Okay, so in your packet, you do have the AP Physics equation sheet. So there are two sides to this that I want to talk about. So this first side goes over some important things. So these are our constants, okay? And we'll see these come up. You don't have to memorize them. They're on the back. We also have our unit symbols. So what do all these units mean? Like I said before, we have our prefixes, and that is for the metric system. Here's a really cool one. They actually give you values of trig functions that we will often see. Now you see there's 0, 30, 60, and 90. We do see those a lot. They're just easier to deal with. Okay, so if you're looking for sine of cosine of these, don't waste your time, flip to the back. And finally, we just have some common things that we're assuming during this test or during this class. On the back, you'll find all the equations. By the end of this class, you will understand all of these equations, where they come from, how to derive them, okay? Now, one thing I want to note is that over here, we have what all these different things mean, okay? So it should be kind of easy for you to look back and forth. We'll also be writing on this and writing down what all these different things mean, what are their like common names, things like that. So, as a friendly reminder, if you're a student in my class watching this, first day of school, it's a half day. We have an open practice packet quiz to assess your skills. So this is kind of like our pretest, your first assessment with our standards. So thanks for listening. If you have questions, you can reach out to me and I will be glad to help you.